Hello everyone, welcome back to a new video of this section of my channel entitled How to Start With. On this occasion, we are going to deal with the legend, the Arduino UNO. I'm going to make it work using Lynx, which is a driver almost discontinued, but still available and also very useful, especially for beginners who are starting to play with LabVIEW, a development board like this one. Let's start it. As usual, you can navigate through my videos, and apart from this introduction, which is section 1, in section 2, I'm going to cover the most relevant technical features of the Arduino UNO, with a special interest in the GPIO port and also the analog to digital converter. In section 3, I'm going to define what are the drivers necessary to make work this board in LabVIEW. In section 4, I'm going to take a sensor, LM35, and I'm going to run an application in LabVIEW to measure the temperature. Without further ado, let's start it. About technical features of the Arduino UNO. First, I'm going to start with the analog to digital converter. The characteristics of this converter are middle of the road, so are pretty standard, but still very useful for many applications that you are going to develop in the laboratory. I say that, okay, because from my point of view, the most significant weakness that you are going to find in the Arduino UNO and in general all the family is the number of bits. Only 10 bits, which is going to be translated into a low resolution compared to other boards, more affordable one that you are going to find on the market. The sampling rate is also modest. It's just 10 kilosamples per second, which is going to allow you to acquire signal up to 1 kilohertz. The range is something that I do like. It goes by default from 0 to 5, but it's adaptable. You can program it, and I usually use, if I have a low signal that goes from 0 to 1 volt, I use an internal voltage reference, okay, that it's 1.1, compensating in temperature. If I do that, okay, I'm going to improve the resolution 5 times, more or less. But if I have a signal that is higher than 1.1, I can use also the external AREF pin, okay, which in this pinout that I have here, it's just here. There you have a direct access to the voltage reference of an analog to digital converter, and you can improve the resolution, which is the main weakness of this board. About the ports, so you have from in this side from 0 to 5. So you have all of them okay, are located in this side. Of course, you have a multiplexer because you have a single analog to digital converter. So all the channels go to a multiplexer and then are going to be connected to the analog to digital converter. So watch out with the speed that you are going to switch into these different channels. You have to give some kind of delay in order to compensate, to charge, discharge all the internal capacitors that you have in this multiplexer. Okay, let's go now. Let's go move into the GPIO port. General output input port or GPIO. So in the Arduino UNO, we have 14 pins that goes from 0 to 13. So all that pins are in one side of the board. And this one, we have the first one, the 0, and here the 13. The 13 also is connected, important thing, to this LED that is internal one that is there. We can use for whatever thing in order to indicate whatever thing. Also very important, 1 and 0 are also used for serial communication, something that is going to be needed because we are going to establish a communication with the PC by links. And then the levels. So it is a CMOS logic level, means that a high value of 1, okay, in the digital port is going to be translated into 5 volts, and a 0 or low level is going to be translated into 0 volts. Another important thing is the many of that pin, in total 6 of them, allow PWM signal, so you can configure that. Also, you can configure that with a pull-up resistor internal, so that means that by default is going to be 5 volt the output, and also useful for many applications. So yeah, that is in general the thing that you have to know about this general input-output port. Let's go now to move into the things that we need in order to make it work in our computer, the drivers. Drivers. All the time that we have to install driver, the application that we have to use and to open, it's NI package management, which is the one that I have here. So in this case, the thing that we are going to do is to go to browse products, and here I'm going to search hobbyist. This is the driver. Okay, so I'm using the community version 2025 Q3 version, and this driver also called in the past as links. It comes by default. About links, about this driver, I have to say that there is a project that is almost discontinued. Okay, so no new boards are going to be supported by this driver, but still is available, and NI gives some kind of minimum support. Also, the forum is very active in ni.com. And for beginners, I think that is a very, very useful tool. The Arduino UNO development board, it's covered, so it is a good option. As I told you before, with this version of community version, this driver comes by default, and very important. So this driver works only under 32 bits. Okay, if you have 64 bits of the LabVIEW, it's not going to work, it's going to fail. All right, so another one that is going to be needed just in case, okay, because it's very general, and also gives support to the serial port, USB port, is Visa, NI Visa. So we are going to search now, and here it is, NI Visa. It's a driver that I have already installed it, okay, and if it is not your case, here install is going to appear, click, and then next, take all the default options, and it's going to take time, this one, okay, to install, but install it, because it's going to provide support for many ports, among them the USB and the serial port. Before going to Max and configure all the parameters in order to make work the Arduino UNO, it's important to open the device management in Windows and see that when you connect the Arduino UNO, it's going to appear there. Here it is. So if you go to port, okay, now appear here as Arduino UNO. If it is not the case, or you have some kind of warning after connecting it, I think that the best way to solve that problem is to install IDE. That is the environment that the Arduino uses in order to program this device. With it, is going to come a driver that is going to provide support for the chip that you have on the board that make a conversion between USB and serial port. Okay, so once that is done, okay, I will open the Measurement and Automation Explorer. I'm going to roll down here devices and interfaces, and here it is, okay, content. I'm going to change that the nickname, and I'm going to set here Arduino UNO. Okay, then I'm going to save, and finally, remember that, especially if you use some kind of converter from GPIB port to USB, and the thing that you have to do is go to Tools, Visa option, and Passport, check that the tulip is like that. If you are using this kind of converters, okay, probably you have that enabled. So remember that you have to disable as it is right now. Otherwise, the Arduino UNO is not going to work. Believe me that it took me a long time to realize, and that should be disconnected to make it work. Right, so now is the moment to install the firmware and make it work, but to do so, we are going to open LabVIEW. Here we are in LabVIEW. As usual, I have created a project, and inside this project, I have a BI that is I have called as index. In this browser of a project, you can go to Tools and then Hobbyist. Also, you can do it directly from the BI in the same way, Tool, Hobbyist, and then Firmware Wizard. And now the thing that we are going to do is to select here our board to install this driver that is going to facilitate the communication between the PC, LabVIEW, and the development board. Arduino, this is our brand, and here, okay, is going to be Arduino UNO. Right, next, now we have to select the board. Appear here as Arduino UNO because we adjust the name of this device in Max. Next, and now the thing that we are going to do is to chart this firmware. Remember that the firmware it's going to cover a lot of boards and also some extensions, and it's pretty big, okay, the one that we are going to install, but very useful because it comes with a palette of BIs in order to control many boards, okay, not only Arduino UNO but also some hats and some shields. Okay, so everything done, the links is installed, and now we are going to verify that with an example. So we are going to launch the example. First, we are going to select here the port, and we are going to run. Basically, the thing that we are going to do is to turn it on, turn it off, the LED, the internal one. So right now is off. We click, okay. So here it is this one that you have there. So off, on, and as you can see, works. And now is the moment to do something more interesting. The thing that we are going to do is to take the temperature of this sensor that is a LM35. All right, here we have our experimental setup with the LM35, which has 3 pins. The one in the middle is the voltage proportional to temperature, and is connected to the A0 of the analog to digital converter, and then 5 volts in order to supply the sensor, and also you have to connect that to ground. You have the schematic also there, and now the program. The program, the most important thing, is I will not do it from the scratch. Instead of that, I'm going to save time using the examples that you have. So help, find examples, and now search and links. And in links, I'm going to use this one, analog read to one channel BI. Double click, now Control E, I'm going to select everything, Control C. Now I can close. I'm in my program, okay, my index, and now I'm going to paste. Okay, wonderful. Control E, I'm going to rearrange things here, okay, and now we are going to see what we have under the hood. So as usual, the thing that we have is a while loop that is going to repeat over and over till you press stop. Or in the case that you have some error in the communication. This green wire that you have here is the error. So the program that you have is initialization. Typical thing that when you connect to some instrument, I will not touch anything here. This is the serial port. The serial port is something that I have to adjust because we did in Max, and here it is, Arduino UNO. All right. Then also we have the channel. The channel is here. Okay, it is a 0. Perfect. But look that this channel goes to this one that you have here. Okay, it's not necessary to open it. Okay, it is a polymorphic one. You can roll down, but I will put it in automatic. I didn't say anything about that, but also automatic, I will not touch anything. Important thing. So once you stop or there is any error, you are going to abort the while loop and you are going to enter here. So it's very important that you get used to close or to stop the program, okay, clicking here. Because if you are the one that love to stop the program here, okay, you are going to get a problem. The problem is that you are not going to arrive here and you are not going to release. You are not going to close the communication and you are going to have an error. Sometimes this error, it's going to crash out totally the communication with the Arduino, and you have to disconnect the Arduino and to close LabVIEW. So please, if you want to avoid problems, if you want to avoid problems, yes, the thing that you have to do is to click here and stop the program there. All right, so now let's go to finish our program. That it's I'm going to make some room here because the thing that I have to do is to multiply this value by 100. So I come here, this numeric multiply. Now connection here. Okay, if you multiply the value of the LM by 100, so it's going to give you directly temperature. Then another thing that is important, that is going to repeat as fast as the Arduino can take this measurement. I don't like that, okay? So I prefer, I don't want to stress too much the Arduino. So the thing that I'm going to do is I'm going to go for timing and I'm going to wait. I'm going to wait here. This is the wait in milliseconds. So create constant and now 500. So that means that my measurements are going to be taken each half second, which I think that is more than enough. Only one thing left, that is to this one, that it's going to show the results. So properties and properties, I'm going to put here in the Y, I'm going to give auto scale, okay? And only one thing, I don't like this error. Also, I'm going to remove that and remember this trick, secondary button here, and now create an indicator. I prefer that one. That is going to give, it's going to give more, okay, interesting information about the errors. So everything done. Now is the moment to run, okay, and to hit my hands. Yeah, there it is. Okay, nice. Almost 20. A little bit chilly here. Let's go. Yes, so I'm touching and that goes up. Not that fast as it should be. Okay, all right, it's working. Okay. Right, so wonderful thing. Remember that if you want to stop, you have to click here, avoid at all costs clicking there, all right? Right, so that's all from my part. I hope that you find this video useful, and I hope also to see you soon. Bye-bye.